Okay, problem number 15 and 16. We're being asked to do some solving now, right? All the rest of them will be solving problems. So this first one is saying state all of the zeros of x to the fourth minus 7x cubed minus 8x plus 56 if we know that x equals 7 is one of those zeros. And so what we're going to do in this case is, again, if I tried to break this down and factor it, I'm not going to be able to do it. I don't know how to factor something that looks like that, okay? Or we might be able to factor something that looks like that, but we're going to use the 0 to help us out. Okay, so in this case, I'm going to do a division problem. So this is a nice synthetic division. I'm going to take the 7 on the outside and do a synthetic division. Okay, I'm going to say 1, negative 7. I don't have an x squared, so I have a 0. Okay, negative 8 and 56, positive 56. Okay, so let's do our long division. I'm going to bring down my 1, and I'm going to multiply, and it looks like I got 7. When I add, I get a 0. Multiply again, I got a 0. Add down the column, another 0. Multiply by 7, another 0. Negative 8 plus 0, I got a negative 8. 7 and negative 8 is negative 56. Okay, so it looks like 56 and 56 is a 0, no remainder. Okay, so let's see where we're at. Okay, 0 was my remainder, which means negative 8 is the end number. We call that the constant. Okay, I don't have any x's or x squareds, and that means 1 is the x cubed, which means after I divided away this expression, x equals 7, okay, it looks like I'm left with x cubed minus 8. Okay, I need to get more zeros from x cubed minus 8. There's apparently 3 other zeros, so let's see if we can figure out what they are. Okay, I need to set this equal to 0, and I need to factor it. Well, guess what? This is one of those sum of cubes, difference of cubes. Okay, so this is going to turn into x cubed minus 2 cubed. Okay, and I'm going to come up top here. Okay, x cubed minus 2 cubed factors into x minus 2 and x squared plus 2x plus 4. Okay, so now I can break it down a little bit more, right? I can say this is a factor. Great, I can set that equal to 0. And this expression right here does not factor anymore, right? X squared plus 2x plus 4 doesn't factor, right? So I'm going to say, here are my zeros. 7 is a 0. X equals 2 is a 0, right? That's an easy one. If I set x minus 2 equal to 0, I can solve that very easily and get 2 as a 0. Okay, my last one, when I set x squared plus 2x plus 4 equal to 0, I need to use the quadratic formula to solve this one, right? I can't factor it, and I can solve every quadratic using the quadratic formula. So I'm going to say negative 2 plus or minus, okay, the square root of, well, b squared minus 4ac in this case would be 4 minus 16, which would be negative 12, all over 2, okay? So I can simplify the square root of negative 12. It's going to have an I in it. The square root of negative 12, I'm going to do that over in this little space here so you can see it away from the whole rest of the problem. The square root of negative 12 is really the square root of 4, square root of 3, and the square root of negative 1. Well, this is 2. Okay? Square root of negative 1 we write as I. Square root of 3, well, that's the square root of 3. I can't really do anything with that. Okay? So I'm going to now turn this into negative 2 plus or minus 2i root 3 all over 2. I have one more little simplify to do for these zeros, okay, and that's going to be all these 2's on the outside. I have like negative 2 over 2 that can be simplified. I have 2 over 2 that can be simplified. I'm going to divide away all those 2's, and I'm going to end up with negative 1 plus or minus I root 3. Okay, so this expression right here represents 2 what we call complex zeros. Okay, so I have 4 zeros like I should, right? Highest exponent of 4, I should end up with 4 zeros. Here they are. X equals 7, x equals 2, negative 1 plus I root 3, and negative 1 minus I root 3. And those are my 4 zeros. Okay, so that's all they were asking us to do. Okay, problem number 16 is very similar, except we're going to have to do division twice in this problem, right? Because we have this giant expression, x to the fourth, x to the cube, minus 7x squared, minus 9x minus 18. We don't know how to factor that, right? I'm going to start off by taking this first expression, 3, and I'm going to do the same thing like we just did in 15. Okay, I'm going to do division, and I'm going to say 1, 1, negative 7, negative 9, and negative 18. Didn't miss anything. 4, 3, 2, 1, 0. That's good. Okay. So I'm going to bring down my 1, and let's do synthetic division again. 3, 4, 12, 5, 15. Okay, it looks like a 6 comes out of adding these together. and a positive 18 at the end. That's good. No remainder. Okay, so here's my answer to this first synthetic division. Okay, remember this is constant x squared, x cubed. So it looks like x cubed plus 4x squared plus 5x plus 6. Okay, I still can't factor this expression, which means I can't find any remaining zeros. We should be able to break down a cubic more. So I'm going to come over here and I'm going to do the same thing. I'm going to use this other 0. If -3 is a 0, I can divide away that 0. Okay, and here's where I'm at. I'm going to say put the numbers from this new expression, 1, 4, 5, and 6. And I'm going to do another synthetic division and try to make this expression even smaller and simpler and easier to factor. So I'm going to bring down the 1, -3, and when I add down the column I get another 1, multiply again and I get a -3. When I add down the column I get a 2, one more multiplication and it looks like -6. Okay, 0 remainder again. That's good. That if things are zeros, I shouldn't end up with a remainder, so that's a good check. Okay, so I'm going to say now I have x squared plus x plus 2. Okay, so now I need to look at this and say, okay, now this is something that I could potentially solve. I know how to solve quadratics. Okay, and so now I need to look at this and say, how do I solve x squared plus x plus 2? Okay, in this case I can't solve x squared plus x plus 2. There's nothing that multiplies to 2 that adds up to positive 1, right? So this is not factorable as solving. So just like the one above it, I'm going to have to set this expression equal to 0 just as it is. This doesn't factor nicely. I have to use I have to use the quadratic formula to solve a problem like this. Right? So I'm going to say in this case -1, okay, plus or minus, and in the inside I have b squared would be 1 squared minus 4 times 2 times 1. Well, that's 1. Okay, so let's do it off to the side. B squared would be 1 squared minus 4 times 1 times 2. Well, that just says really 1 minus 8. That's -7. Okay, all over 2a, which is just 2. Okay, so I don't really have to do anything with this. The -7 doesn't simplify. I just have to bring out the I. Right, -1 plus or minus I root 7 all over 2. Okay, and I would say this is 2 of my zeros. Okay, I'm going to get 2 more zeros up here, the ones that they gave me, and those are the 4 zeros that I'm going to use in my problem. Okay, so problem number 17, I'm going to say we're going to skip. Okay, I put it on there, we're going to do something with it, but we're going to save this one for later. We're eventually going to do it, but we'll do that with graphing. Okay, problem number 18, again, is pretty much the same thing as number 16. Okay, I'm only asking you to state the complex zeros for me. Okay, I want to know what are the complex zeros of this expression, which means you're going to do the division, and you're only going to give me an answer that is the I parts of the problem. Right, so we're going to say in this case, let's do our first division. There's a 4 out here, so I'm going to put a 4, okay, and I'm going to do my first division. 1, 1, -15, -16, and -16. I didn't miss anything. Again, I double checked. Okay, so I'm going to do my quick synthetic. Okay, it looks like I get a 5. 4 times 5 is 20. I get another 5, so I get another 20. -16 plus 20 is going to be 4, and okay, it worked out again. Good, I got a 0. Okay, so here's my new expression: x cubed plus 5x squared plus 5x plus 4. Again, doesn't factor. Even if you tried grouping, it's not going to work. So I'm going to come over here and I'm going to use the -4, right, this other 0, and I'm going to do another division. Okay, so we're going to do it using the numbers in, okay, this expression here. So I'm going to say 1, 5, 5, and 4, and we're going to do our division again. Bring down my 1, -4. Another 1, okay, which means I get another -4. Okay, another 1, and it looks like I'm going to get another -4, which I needed for that to divide. Okay, so here's where I'm at. I have x squared plus x plus 1. Okay, that is the answer to the division, my second division problem. Okay, so again, I have this situation where if I try to factor x squared plus x plus 1, there's nothing that multiplies to 1 that also adds up to 1. So I'm going to basically just say this is as broken down as I can go, set it equal to 0, right, and I'm going to solve. So I'm going to say -1 plus or minus the square root of Well, let's do the b squared minus 4ac over here again. 1 squared minus 4 times 1 times 1. Okay, so it looks like 1 minus 4. 1 minus 4 is negative 3, all over 2a, which is just 2. Okay, so again, I have this situation where I got to bring the I out of this. Negative 1 plus or minus I root 3 all over 2. Okay, and they asked me for the complex zeros. So they're basically saying, what are the zeros in this problem that will have I in them? Well, we just found them. Okay, it's these two right here. And that's the answer to their problem. They're basically saying, what answers will have I? We found two answers that have I. Right? The other two answers were the real number answers, so I didn't have to worry about doing any additional work. I found all of the zeros, and I answered their question.